Mark here, cooking the books and bringing the info. So I've been researching the wave function for about, let's say a month or a little bit over a month now. Since this whole COVID quarantine thing, I've been, just in the house, really studying the wave function and what it is. And really, the short answer is the wave function is a mathematical formula or an expression that associates two variables, right? So it tells you the relationship between two variables. Those variables, one consists of a domain, the other is the range, and the domain is the input, the range is the output, which is the outcome. So the wave function, again, it was pretty much brought about by Erwin Schrödinger, 1927, and again, it pretty much talks about the input, the output, and the relationship between both, right? Also, it's more than that, though. It's a little bit more complex. It also talks about the once you find the wave function, right, which is the probability of locating a particle at a specific time at a particular location. So once you find the wave function, you know everything there is about the physical system. Once you locate the wave function tells you the probability of finding a particle at a set place at a set time. So it's way more complex than just a simple associations between input and output. But again, it's so important, right? Like, now learning about it, right? Having information without practical application is useless, right? So how do you practice? Like, what's the practical application of this information? Like, why do I study this stuff? Why is it important? Why is it necessary? I haven't a very, like, I wouldn't say in depth. I would say I have a very shallow understanding. I'm not even gonna lie. I'm gonna sit here and be honest. Like, it's very complex and profound, right? So my understanding of it is not too deep, like the Erwin Schrödingers, the Thomas Young, Einstein. These were the scientists that study this stuff. Having somewhat of an understanding of the wave function, I can see it in real life. Like, when you understand the wave function and what it means, and finding the probability of locating a particle, once you find out what that means, the importance of that, then you can look because remember, these are physics of the laws, the quantum physics of the laws that govern our world. We have to understand that, like, physics, quantum mechanics, quantum theory, quantum physics, these are laws that govern the universe. These are fundamental building blocks, right? These are the fundamental building blocks of the universe. So everything that we see on a macro or on a large scale is governed by these the laws of physics. And when we talk about the laws of physics, you have to completely come in with a blank mind, right? You have to get rid of all your preconceived notions, all your precognitions. You have to get rid of all your premeditated thoughts, right? You have to come in with a complete blank mind, right? You have to unlearn everything you've learned, because the laws of physics are completely nonsensical, irrational, and illogical. Nothing in physics makes sense, right? When I say makes sense, based off our 5 base sensory system that we've all that has all been conditioned, right? Our 5 base sensory system have been conditioned. So when you go into studying the laws of physics, it's like everything that you knew makes no sense. And I'll give you just a real quick example, because of the interest of time. An electron, for instance, a particle, right, can exist in infinite possible states, right? It's called superposition, meaning a particle, the electron, right, or the proton, whatever it is that you're seeking to locate with the wave function formula, that before that location is the probability, because you're not finding it, it's the probability of finding it. Before you get to the probability of finding it, the electron or the particle exists in all its possible states, and it's called superposition, right? Once you find the probability of locating it, then you have what's called probability distribution, which is a list of outcomes, right? And again, it's all about probabilities, right? Nothing is deterministic, and it's probability because of what's called the uncertainty principle. and that's a whole nother discussion. But the uncertainty principle makes certain that you will never ever find it exactly. You'll get a probability, an approximation of finding it, but you won't find it exactly because of what's called the Heisenberg uncertainty principle, which is another discussion. But what's crazy is, like I said, an electron can exist in all its possibilities, all its infinite possibilities. Like, it can exist in all states simultaneously, right? So that makes no sense logically. Think about it. Something can exist in all possible states at the same time, right? Then another law that makes no sense is quantum entanglement. You can separate a particle infinite miles apart, or a distance of infinity, and yet if you interact with one half of that particle, the other half responds simultaneously, as if it's in the same room, or not just in the same room, as if it's still whole, right? You take an apple and cut the apple in half, take half the apple to China, the other half is in New York, and you conduct some kind of laboratory experiment on that half in New York. The half in China is reacting as if it's being it's being performed on, right? Yet they're thousands and hundreds of thousands of miles away from each other. Quantum entanglement, that makes no sense, right? So the laws of physics don't make any, it's not rational, it's not logical, and you can't go into it with a left side brain thinking. Left side is analytical, critical, mathematical, very logical, evidence and conclusive evidence based, right? That's the left side. The right side of the brain is more intuition. It's the imaginative brain. That's the side you have to go in with. You have to go in with an open, imaginative mind to understand physics. And so yeah, the wave function is what I've been really looking into. And I say this again, I see the wave function now that I have somewhat of an understanding of the wave function. I see the wave function in a practical sense. When you see a Michael Jackson, when you see a Mike Tyson, when you see a Michael Jordan, when you see Alexander the Great, when you see Marcus Aurelius, a Barack Obama, when you see anyone who have done achieved extraordinary greatness in this three-dimensional universe, anyone, Mark Zuckerberg, anyone who has achieved I mean, going above and beyond in terms of greatness, the heights of the pinnacle of greatness, you're witnessing wave function, right? You're witnessing wave function, but you don't know. Like, and it's to no fault of your own. The average person, the people who are achieving this greatness probably don't know. You see what I'm saying? In other words, we put in practice the laws of physics, the laws of wave function, collapse, without knowing that that's what we're doing, right? So we carry out these things anyway, because again, we are the universe and we're governed by these laws. So we carry out these laws without necessarily knowing the technicals of these said laws. And that's, again, that's no knock, or it's not a knock on anyone. I'm just trying to tell you how once you start studying this stuff, you're able to look at it and see it play out on the physical universe. It's kind of like having a playbook, right? You're a basketball coach. You have all the plays in front of you, and then you watch the game and you see all the plays playing themselves out. Imagine the players, though, don't know about the playbook. For whatever reason, you use your imagination. The players have no idea about this playbook, but you do. And somehow you are able to instill the plays into their minds without them even knowing that you're instilling the plays. And now you sit back and you watch all the plays in your playbook manifest. Well, that's what it's kind of like for someone like myself right now, who's studying this stuff and getting a grasp of it. I'm witnessing, oh wow, so that's what it means, the probability of finding the particle in a set place at a set time. And here's the thing, here's one more thing before I run. The particle, if you want to see the particle in a practical sense, if you want to see what that probability of finding the particle, what does that mean? Look at the word particle, and then if you want to see what that is, what the particle is, right? Because once you find the wave function, remember, of the particle, you get all the physical information about the system. That's the idea of Schrödinger's equation, right? Schrödinger's equation, right? If you want to know what that particle is and what it means in practical sense, look at a bit, a computer bit. And if you understand what a computer bit is, or not a byte, but a bit, what the computer bit is, it's the smallest unit of digital information. Look at a pixel. right? Pixel or a smallest unit of digital imagery, right? Pixels are what allow this phone video to work and TVs and stuff like that. It's the smallest unit of digital imagery, right? That's a pixel. A bit is the smallest unit of digital information. If you understand what a bit and a pixel is, you'll know what that particle is. You'll know what that particle is when it says the probability of finding that particle, which is the wave function. If you know what that bit and the pixel is, you'll understand what that particle is, because the bit and the pixel is an extension or a replication of what physics calls the probability of finding the particle. I could keep going because I got some, I'm gonna stop now. I don't want to give y'all too much, but it's some real good stuff. I'll talk to you later. Peace.